So let me get started here. Sometimes I like to discuss the quiz in class like right after we have it, but today is not that day because we're just a little bit behind schedule, unfortunately. And so what I will do probably is work the quiz out and like post a separate little video where I talk about the solution to the quiz so you can watch it later. All right? And then hopefully I'll have the quiz back to you graded sometime pretty soon. So, you know, I do post solutions to each quiz and I do return them to you once they're graded, all right? So, yeah.
So you put that video on YouTube or on campus?
On YouTube, yeah. And so I will, all the videos for this course, I put them in the playlist for the course on YouTube. So like, I never post a video on Canvas if I can help it. So, I mean, every once in a while I'll teach an online class and they make me post something through Kaltura or some such nonsense, but all right. So we talked about how to solve two equations and two unknowns, right? And unfortunately, I accidentally like ruled out section 5.1 homework when I told you guys like what to study for this quiz, which was dumb because of course we have covered half of section 5.1 already, right? Like the two equations and two unknowns, we've done that. I should have put that on this quiz, but I didn't precisely because why? Because I told you guys you just had to study, you didn't have to study section 5.1 for this quiz, right? So that would have been mean if I'd put section 5.1 problems. Although as a generic point of order, like I intend for the quiz to be an echo of what I've done in the week before. So in that sense, this quiz is not a good representation of last week, right? Because like last week we did a lot of two equations and two unknowns, right? So like that really should have been on this quiz, but I didn't because I told you guys I wouldn't test you on 5.1 on the quiz, right? So my own fault, because I had it in my mind that 5.1 was just about three equations and three unknowns, but that's not the case, right? 5.1 in your textbook is where the problems are from two equations and two unknowns and three equations and three unknowns. So let's talk about three equations and three unknowns. So this I've written on the left board over here. Well, my right, your whatever, that one. Let's not get into that. So if you have three equations and three unknowns, it's tricky unless you have a plan, all right? So like the one we worked in class at the end of last week, it was really nice because we were able to add equations and have two variables cancel out at once and like it immediately told us what the third variable was, right? That's not usually possible. Typically, you kind of have to have a strategy for eliminating variables. And so here's a potential strategy that will always work. All right? So here's the strategy. Number one, eliminate variable by combining equations 1 and 2. So the labeling I'm talking about, first of all, just to keep things organized, I label these 1, 2, and 3. Now, you don't have to use Roman numerals if you don't want to. I got started down that path, and here we are. So I eliminate a variable by combining 1 and 2. I eliminate the same variable, right, by combining 2 and 3. All right? When you do that, that gives you two new equations. Let's call those equations 4 and 5. Those two equations won't have the eliminated variable, which means you'll be back to two equations and two unknowns, which you can solve. And then you go back and get the original variable. That's the roadmap. That's the view from, 50 feet up or whatever. Let's put that into practice on this problem. All right? So you guys tell me which variable should I eliminate? Eliminate y? All right, so our goal, eliminate y from 1 and 2. And so the way I'm going to do that is I'm going to do twice equation 1, which is going to give me 6x plus 2y plus 6z equals to 2. Do you guys get that? I multiplied equation 1 by 2. Why did I do that? Because equation 2, right, what's it look like? Well, it's x plus 2y minus z equals to 2, right? So by multiplying equation 1 by 2, I have done what? I have made them match up, right? And now I can subtract these equations, right? And what happens? I get 5x, the y's cancel by y'all's design, and minus a minus is a plus, so we get plus 7z equals 2 minus 2, otherwise known as 0. All right, so we're going to call that equation, I said to label that equation 4, which in Roman numerals is this. But again, if you want to call this just 1, 2, 3, 4, that's fine. You don't have to use my Roman numeral labeling if you don't want to. Okay, so at this point, we've achieved goal number 1. We eliminated variable y from 1 and 2. All right? Now I want to eliminate y from 2 and 3. What should I do? Ah, yes, so likewise, I'll do it over here. So you said multiply, you said equation 3 by 2, right? So I'll do equation, I'm just going to write down 2 again. 2 is just x plus 2y minus z equals to 2. And then you said twice times equation 3. That gives me what? That gives me 4x minus 2y plus 8z equals to 8. All right? And then this time we don't subtract equations. What do we do? Yeah, we can just add these equations because that'll make the y's cancel out, right? Our goal is to eliminate the same variable we did in step 1. So this gives us 5x plus 7z equals to 10. And this is equation 5. Any questions so far? So at this point we have achieved step number 2 in the roadmap, all right? Now we're to step number 3. We want to solve 4 and 5 together, right? So look at what we face. So at this point I usually just write the equations I have down again. So all right, so we face, what do we face? We face, 5x plus 7z equals to 0, and we've got 5x plus 7z equals to 10. Well, that's nice, right? So what does that mean? What does it tell you? Oof, yeah, this says that 0 equals to 10, right? Otherwise known as, I mean, it's not really unhappy because this means we can stop working on the problem. We've done mathematically logical steps and we have arrived at a contradiction. What's that mean? That means there's no solution. So, not my fault. I copied this out of the book, right? I mean, this is a book problem. So we tried it. Shall we try another one? I mean, it's not wrong. It's just, we're done, right? I know it's not very, it's more satisfying if we can find our way to an answer, right? As opposed to this. Now, graphically speaking, guys, this is actually what this means. So like, just to let you know, 3 variables, the equation of 3 variables, if like x plus y plus z equals to a constant, that's the equation of a plane in 3 dimensions. And so like geometrically what this means is these 3 plane equations, what they actually are maybe they're 3 planes which are like parallel, right? And so those parallel planes never intersect. If you have planes which aren't parallel, like say the bottom sheet here and the upper sheet, well, the 2 planes which aren't parallel, they'll intersect along a line, right? And then if you add a third plane into that, then that fixes a unique point. So we want 3 planes which are not parallel in order to get like a point, which is the solution. Obviously, you're not required to know the geometry here because, well, we don't do 3-dimensional coordinate geometry in here, do we? Let's see here. So let's look at another example. Let's see here. Let me try another one from the book. Hopefully this one will not be no solution. We'll look at x plus 3y minus 6z equals to 7, and 2x minus y plus z equal to 1, and x plus 2y plus 2z equals to minus 1. Now let me just check. I try to make sure I've actually copied the problem down correctly because I sometimes mix problems. 7, 2x minus y. X plus 2y plus 2z equals minus 1. All right. Very good. Okay, so let's call this equation 1, 2, and 3. See if we can solve it. And you know, this roadmap's not written in stone. You can modify it. Like you should understand the spirit of the roadmap as well, right? Like this one, goodness gracious, like this one just yells to me, eliminate x, right? So what I'm going to do here is I'm going to take equation 1 minus equation 3. Right? What's that give me? If I do equation 1 minus equation 3, see the x's cancel, and we get y minus 8z equals to 8. Let me call that equation 4. So I'm eliminating x. So here's the way this works. To make the next equation, you have to be certain that you use equation 2. If you don't use equation 2, you're just going to go in a circle. All right? We have to use all 3 equations as we eliminate the variable to be safe. So how should I eliminate x from 2? I'll write down 2 here again. 2x minus y plus z equals to 1. And how about I write down twice 3? Yeah? If I do 2 times equation 3, what do I get? I get 2x plus 4y plus 4z equals to minus 2, right? So, yep.
Back to
Previous step, yeah?
yes. So negative 6z and positive 2z, we're not subtracting 2 from 6.
So minus 6 minus 2 is minus 8.
Right, where are you getting the minus 2? That's where I'm confused.
Oh, I'm subtracting equation 1 from
Oh,
equation 3.
okay.
Yeah, you're fine. It's because I haven't written it out. See, there's a balance to be struck here, right? Every time you write one of these equations down, there's a chance you're going to copy it wrong. Right? Every single time you write an equation, you risk a copying error. So, like, there's a balance to be struck between just writing tons and thinking. But on the other hand, if you think too much and don't write enough, that also makes you make errors, right? So, like, you got to find some kind of balance between those two things for yourself, right? And then what do I subtract now, right? So take these, subtract, what do I got? So help me, if this problem turns out to be no solution, I will pull what little hair I have left out. Let's see here. 2x minus, so that's minus 5y minus 3z equals to a 3. That is equation, I'm calling it 5. Yeah, okay, I think this is going to work out more interesting. Right? Now, at least my equation 4 and 5, they're not the same stupid equation, right? With different numbers on the right-hand side, right? These are genuinely different equations. We're going to find a unique solution in this one. So what do we face? What do we face? We face y minus 8z equals to 8. And what else are we up against here? Minus 5y minus 3z equals to 3. All right, so that's what 4 and 5 are. How do you solve this two equations, two unknowns? I mean, you got options, right? Yep.
And it would be easier to just times the top one by 5.
Times the top one by 5? Okay, cool. I'll do that one. So let's see, top one was 4, right? So this was 4, this was 5. So technically speaking, down here we're going to look at 5 times 5, 5 times 4. 5 times Roman numeral 4. That's the equation we're looking at, which is 5y minus 40z equals to 40, I think, right? And then we can add those. I like that. So you guys really, you're very elimination heavy. Like some classes there's at least a few supporters of substitution. None of you are supporters of substitution. I like it. Like we're going to put all our eggs in one basket. You know, which is, you know, become a really important thing to talk about lately. Let's see here, 43z equals to 43. Oh, so apparently z is equal to what? Yeah, z is equal to 43 over minus 43, which you guys told me is negative 1. Okay, great. Now what's y equal to? Y is equal to 8 plus 8z, right? Which is 8 minus 8, also known as 0. How do I know that? I'm using equation 4, right? By 4. So I took 4 and I solved for y. All right? So we figured out y is 0. What's x? So basically we're in step, in my roadmap, essentially we're in step 4 here, which is substitute the results of 3 into any one of the original equations, right? So whichever, I mean, it doesn't matter. Let's use equation 3, you know? What's 3 tell me here? It tells me x plus 2 times what? 2 times 0 plus 2 times z was minus 1, right? Is equal to minus 1. What's that tell me x is equal to? Minus 1 plus 2, which you just told me is 1. All right? And then what's the final thing we do in one of these problems? We state the solution, right? So let's gather everything together. Thus, solution is we've got x equals to 1, y equals to 0, z equals to minus 1, which we write as 1, 0, minus 1. So there you go. That's the solution.
Does it matter what order you provided in?
The numbers, it does. In the triple, it matters. If you use the letters, like I could write y equals 0, x equals 1, z equals minus 1. I could write the x, y, z in different orders, right? But the triple, this right here, this is the x slot, this is the y slot, this is the z slot. Just like when we write ordered pairs, x, y, x comes first, y comes second, same idea. But see, the answer here is not one thing, it's 3 things. Right? Because we say we're simultaneously solving all three equations. That means if we put x equals to 1, y equals to 0, z equals to -1, it makes not 1, not 2, no, all three of the equations are true all at once if we plug those numbers in. Try it out, see if it works. Try it out. Put x equals to 1, y equals to 0, z equals to -1, see what happens. X equals to 1, 1, y equals to 0, 0, z equals to -1. So -6 times -1 is 6. 1 plus 6, 7. Right? 2 times 1 is 2. Minus 0. 2 minus 1, 1. That works. Plug it in. 1 plus 0 minus 2 is -1. Right? We can always take the answer that we get, right? Especially like on a final exam or a test. Take a second. Take your answer. Plug it into the original equation. If it doesn't work, you made a mistake, right? Maybe you can find it. For me, personally, when I'm working this kind of problem, I usually make the mistake in like the last step. So let's be optimistic and say that you make a mistake in the last step too. You can easily fix it, right? It's worth your time to check your answer. I give more partial credit for an answer which is wrong, but includes the sentence, I know this is wrong, I didn't have a chance to fix it. You know, that is worth something to me, that you've checked your answer and seen that it's wrong. Now, I prefer that you fix it, right? That's worth more, but, you know. Okay, so please, you know, go work the section 5.1 homework. And also, you know, work on your I have a mission, right? The mission's due when? What's that? February 14th? What is that? Valentine's Day, that's right. Show your love for math. All right. So let us go on here. Yep.
Is the mission graded for accuracy or completion?
Yes. I mean, I have a grader, so it should be graded for accuracy. I mean, they got to do something. So. Other questions? Oh, lest I forget, let me turn the, I made a fresh new attendance sheet for you guys. So keep in mind the attendance sheet is what matters more. I mean, I top hat out of obligation, but not from the heart. My heart keeps attendance on this sheet. What can I tell you? So what is today's date? It is the 24th. So we'll start this new sheet fresh right here. Hopefully it's got everybody. Hopefully it's got everybody. So you got to just find your name and check it. If you're not on here, if you could add your name to the back, I guess. All right, so any questions? So I hope I've showed you enough about how to solve two equations and two unknowns. Now you go try it for yourself, right? Now the mission you have to turn in, right? It will be graded for completion and accuracy. The recommended homeworks are not collected, right? But I do recommend that you do them, right? At least enough of them so that you're confident about what you're doing. I have made a point of asking recommended homeworks which are odd numbers, right? Which means that the answers are in the back of the book, right? So you can check and see if you're right or wrong and so forth and adjust accordingly and or ask me questions about them or whatever, all right? Does that make sense? The textbook is sitting outside my office, so if you ever need to look at it, you can look at it there, right? I leave it in the, there's like a drop-off box outside my office where it's just sitting in, okay? So, anyway, just all that. The other thing, of course, if you're new to the course, do keep in mind that you should look at the course planner. That tells you where we are and what we're doing. So, let me put this away here. All right, so Did you guys move the camera? Not at all? Oh, man. So it's just been... I forget, I need to tell you guys about this. So the goal is to try to make sure we, get on the camera whatever is written on the board. I don't think I've erased anything yet that I didn't. I had the camera was focused on the left board, so I don't think we missed anything yet. So there it is. To those watching at home, sorry. So sometime that's going to be you guys, right? Because you'll be sick and you'll need to watch this. So we need to try to, I'll try to remind you guys to move the camera. I just forgot to remind you to move the camera. If you sit in the back, I need somebody to help me with that. Otherwise, I will forget. I am my own worst cameraman. And you don't have to follow me around. It's just important that, we generally try to put the board where I'm writing, try to put the camera where I'm writing as a general point of order. So, okay, so let's talk about absolute value and distance. So let's see here. If I've got 2 points on the number line, right? Like A and B, I can figure out the distance from A to B. It's equal to the absolute value of B minus A. So if we take the absolute value of the difference of two numbers, it tells us how far apart they are, right? So like, for example, let's see here, what example am I on? 3. So the distance, say, from -3 to 13, we take the absolute value of, like 13 minus a -3, which gives us the absolute value of 16, which is 16, right? So let's talk about absolute value. How does absolute value work? What's the definition? Absolute value of x is x, well, it's minus x if x is less than or equal to 0, and it's x if x is greater than or equal to 0. There is a nice formula for absolute value. The absolute value is just straight up the square root of x squared. That's absolute value. The square root of x squared is the absolute value of x. If you don't believe me, well, let's take it out for a spin. What's the absolute value of -5? You say it's 5. I say it's the square root of -5 squared, right? Which is the square root of 25, which is 5. So we agree. Now, do I actually square numbers and then square root them to take absolute value? No, of course not. But my point is that's a formula for it, okay? When we take the square root of a square, we get the absolute value of what's inside. That's the reality of the situation, all right? This will be important when we solve equations, because when we take the square root of a square, we don't just get back the thing inside unless we already know that's positive. Like, otherwise we get absolute value. This is actually really important for solving equations. Okay, so absolute value then. What if we want to solve the absolute value of, let's say, 3x minus 2 equals to 4? How should we solve this problem? Yep.
Would you isolate x?
How would I isolate x? Yes. I agree with you, but how do we do that? Yep.
So you take the absolute value of it, 3x plus 2, and then...
Oh, yes. Good suggestion, but in fact, unfortunately, this is not equal to, like, that's not the case. Like, we can't, absolute value doesn't, like, have linearity. We can't break it up into pieces like that. Unfortunately, that we can't, but we can say this. 3x minus 2, right? For this equation to be true, 3x minus 2 has to be either plus or minus 4, right? Either 3x minus 2 is 4, or 3x minus 2 is minus 4. Either one of those possibilities are the only way that we can solve that equation. So then we can follow your advice, isolate the x now, right? So this gives us 3x is equal to 2 plus or minus 4, which gives us x is 2 plus or minus 4 divided by 3. And then, well, okay, so what does that tell us?
So
2 plus 4 over 3, or 2 minus 4 over 3. And we can simplify that, right? Like 2 plus 4 is 6. 6 divided by 3 is 2, right? Or what's 2 minus 4? It's minus 2, right? Or minus 2/3. What was your question? Now, traditionally, students do not like this method. All right, you guys, not a fan typically of this method, this notation. I call this the plus minus notation because it's based on using plus minus, right? There is another way to do these problems, which is just to separate it into two cases and work each one of those cases separately. So let's try that. Let's try that notation, right? So let me work another problem here a little bit differently. Well, we can work the same one a different way if you want. So like 3x minus 2 equals to 4, right? So this gives us, there's two different things that can happen. Either you've got 3x minus 2 equals to 4, or you've got 3x minus 2 equals to minus 4. Those are different equations, but you can solve each one of them just like you solved the equations on the quiz today, right? You're like, I wish these were on the quiz. These are easier than what you put on the quiz, right? So again, name of the game, isolate x, right? So I mean, we're going to get the same answers, right? So when we isolate on the, we put a dividing line here. We get 3x is equal to 4 plus 2. In other words, 3x is equal to 6. So x is equal to 6 divided by 3. X is equal to 2. All right, that's the one side. The other side, we get 3x is equal to minus 4 plus 2, which is minus 2. So x is equal to minus 2/3. So I don't care, guys. You can use the plus minus notation, or you could break it into two cases. It's your business. You can do either one. It's all good with me, all right? But what you need to be aware of is when we solve absolute value problem, there are two answers. Does this make sense? Okay. Let's work some more here. All right. Example 7. So let's look at the absolute value of x plus 1 equal to the absolute value of 1 minus 3x. Let's try this one on for size. Oof. Well, this one's got absolute values on both sides. What should we do now? So think about it. There's like 4 logical possibilities, right? You can either have, the pattern you could have is like plus on both sides. You could have like this is plus, this is plus. Yeah, this is plus, this is minus, this is minus, this is plus, this is minus, this is minus, in terms of the inputs to the absolute values. But when you sort through that, what's always going to happen is you have one side is equal to plus or minus the other side. So the long and short of it is the same idea we did for the last case still works. Like either you're going to have x plus 1 equals to 1 minus 3x, or you're going to have x plus 1 equals to minus 1 minus 3x. If you sort through those 4 logical possibilities, I mean, like, the other possibilities would be like, you have minus this equals to minus that, right? But when you multiply by minus 1, you still get the same equation. Or you have this is plus and this is minus, which gives you this. But if that was minus and this is plus, you'd have minus this equation. Long story short, the 4 different possibilities just collapse into 2 possibilities, and we just need to look at those 2 possibilities, just like the other problem. And we're off to the races. See, because we've got just linear equation, we can solve these, yeah? So isolate x, add 3x to both sides, I get 4x equals 2. Oh, the 1's cancel, 0. Well, that's nice, x equals to 0. I always love it when I love when 0 is an answer. 0 is easy to check. How about the other one? Well, I get, let's see here, I'm going to write it down more time. X plus 1 equals to minus 1 plus 3x, which gives me 2 is equal to 2x, which gives me, you know, x equals to 1 is my solution on the other side. So again, we get 2 answers, either x equals to 0 or x equals to 1. You can check your answers, right? Plug it back in. Does it work? If I plug in 0 into the equation which is given, I get absolute value of 0 plus 1, which is 1, right? On the left-hand side. On the right-hand side, I get 1 minus 3 times 0, which is 1. The absolute value of 1 is 1. 1 equals 1, right? It works. And you can try plugging 1 in. Plug in 1, I get absolute value of 2, which is 2. On the other side, I get the absolute value of 1 minus 3, which is minus 2. Absolute value of minus 2, again, is 2. 2 equals 2, it works. So we can easily check this is and this are both legit solutions to the problem. All right. And let's work another problem here that's kind of, it looks different, but it's actually pretty much the same song and dance. So let's see here. I recommended problem number 17. This is kind of like it. I'll work number 18, 2x plus 3. So by the way, like as I'm making quizzes, I'm generally speaking trying to look at these recommended homework problems to make the quizzes in part. So like recommended homework problems and examples I do in class, those are the 2 things. I'm trying to make the quizzes reflect those 2 things. I may not always succeed at that goal, but that is my goal. So, all right, this looks a little different, right? But the same logic holds, right? So like either I've got 2x plus 3 divided by 3x minus 4 equals to 1, or I've got 2x plus 3 over 3x minus 4 equals to minus 1. How do I solve equations like this? What do you do? So I usually say I cross multiply, right? Basically multiply by the denominator. So this gives me 2x plus 3 is equal to 3x minus 4. The other one, on the other hand, I have to multiply the minus through, right? So this gives me 2x plus 3 equals minus 1 times 3x minus 4, which is what? Minus 3x plus 4. At the end of it, we're always trying to isolate x, right? So let's isolate x. We can do that, yeah? So I get 7 equals to x for this one. And if I add 3x, I get 5x equals to 1. So I get x equals to 7. And I get x is equal to 1/5 for that one. Sorry, I've run out of board to put in steps, but what I did was so this one, I subtracted 2x to the other side. So 3 minus 2 is 1, right? And then I add 4 to both sides. So that moves this over here. 3 plus 4 is 7. So I add 4 to both sides, and I subtract 2x from both sides to get to that. That one, I added 3x to both sides, and I subtracted 3 from both sides to get to 5x equals to 1. So again, 2 answers. All right? If you understand, what we've done for the last 3 examples here, you should be able to solve any of the problems that are like this, all right? There is one other case, right? It could work out. These could be inconsistent too, right? That's possible. You could have the situation where you end up with like the x's canceling and you get like 0 equals to 7 or something stupid. Like that can happen here too. That's still possible, all right? All right. So now I'm going to turn the page here. Yep.
If you have no solution on one side of the or, like, you're never going to have, like, no solution on one side or, like, 3 or something? Is that always going to be no solution?
Well, what are the what are the cases? It depends on, like, what we're talking about precisely. So, like, generically speaking, if we're doing something like, let's say, absolute value of, I don't know, ax plus b equals absolute value of cx plus d, something like that. So what, graphically what those look like, they look like v's. But the v's have slope. This one has like slope A, this one has slope C on the one side and minus A and minus C on the other. And so like the one, you could look at the one side as y equals to like a V like that, and the other side would be y equals to a V like this. So let's say this is y equals Cx plus D, y equals ax plus b. I wasn't intending to talk about graphs today, but your question demands a graphical answer. Because you're asking, like, what are the possibilities? See, if these slopes match up, if a is equal to c, or if they're like plus or minus each other, then these lines are parallel and they'll never intersect, right? So you get the situation where there's one solution, but the other one doesn't. And then if you don't just have this, but if you have these shifted, then you can have the situation where you've got one V going up and you've got one V going down and they never meet. So there's like different possibilities if you just loosen this up a little bit. Now when they have different slopes, it looks more like, maybe this one's slope x and the other one has slope, say, a half x. Let's see here. Or whatever, then there's going to be like 2 places where the v's intersect. And that's what we typically get is 2 solutions. So I don't think you guys have any homework on graphing absolute value function yet. So this is like time travel for like a month ahead in the course or something. But yeah.
But isn't it when like one of the sides is no solution, if you like split it up, then the other side is still true that's the only solution?
If one of the, that's right. It's just that case has no solution. There is still the solution on the other side. Thank you. That's a very helpful, clarifying comment.
That's
Yeah.
the one for the whole.
That's the one for the whole thing, right? Yeah, because whenever we're solving an equation, we're looking for all possible solutions to the equation, right? That's like our general, ninja way, I suppose. Okay, so these are good questions. But I need to go on to the next topic here, which is inequalities. And this will require more of our time. All right? So I'll at least start it today, but we'll probably have to do another 10 minutes on this next time or something like that. So Let's see if I can explain this. All right. Let me use some numbers here just to make it concrete for you guys. Let's see here, example 9. Suppose I'm faced with the inequality absolute value of x is less than 3. What's that mean? Like, let me write this a different way. So it's kind of stupid, but that's the absolute value of x minus 0, right? That's the distance from 0 to x. So if you think about a number line, right? Here's 0, right? Here's a potential solution, x. Where does it have to be? It has to be less than 3, right? So that's got to be before 3, right? Before 3, and also not past minus 3, right? It's got to be somewhere in here, right? In other words, we have to have minus 3 is less than x is less than 3 if we write it as a compound inequality. Yep.
Why can't it be further than -3?
Well, okay, so if x was equal to, for example, minus 4, the absolute value of minus 4 would be 4, and 4 is not less than 3. But also just think of it geometrically, right? If you're going to be within 3 units of distance from the origin, you can't go past 3 or minus 3 because you'd be further than 3 units of distance away from the origin. What's the solution set? So, in other words, this means solution in interval notation is minus 3 to 3. What if we're faced with the absolute value of x greater than 3? What does that mean in terms of distance? That means the distance from the origin to the point x is more than 3. Where are those points on the number line? Oops. So again, they have to be more than 3 units of distance away from the origin. If we draw the number line, where is x? Yep.
So x is equal to 3, so everything past 3.
Past 3, right? So it could be over here, right? X could be over here. That's one possibility, right? But the other possibility is it could be over here. These are disjoint cases, yeah?
Did you write that as like -3 to -3, 3 to infinity?
Yeah, this is the interval that x is in here is minus infinity to minus 3. And this guy over here, as in interval notation, is 3 to infinity. Since the answer includes both of these, we have to use what's called union. So the solution is minus infinity to minus 3, unioned with 3 to infinity. That's the solution to this inequality. So let me just state a theorem here for our reference, all right? There's a theorem that we should remember. Theorem. To solve for, given b greater than 0, the absolute value of a less than b, that's equivalent to minus b less than a less than b. But on the other side of things, the absolute value of a greater than b is equivalent to a less than minus b or a greater than b. And so that, my friends, is how we solve these problems. You have to realize there is an incredible asymmetry between the case less than or greater than. All right? And this continues to be true for more complicated expressions. So like, let's try one. Example 11. Suppose you're solving absolute value of 3x minus 7 less than 1. How do you solve that? So I use the theorem. I identify that what I'm looking at here really, right? I think of this as being like my A, and I think of this as being B, right? So what's this saying? This is saying that the distance of A from the origin is at most 1. But what's more, I mean, just let's get to the point. The point is that this is logically equivalent to minus 1 less than 3x minus 7 less than 1. And then we can solve it. How do you solve inequalities? What are the rules? Yep.
If you divide or something,
Mm-hmm.
you have to switch the sign.
If we divide by a negative number, we have to switch the sign. That's right. We've got to watch out for negatives. But otherwise, it's pretty much the same, right? We can multiply by a positive number, the inequality is preserved. We can add or subtract across inequalities as well. So like I can add 7 across this, right? So like minus 1 plus 7 is less than 3x. Minus 7 plus 7 is less than 1 plus 7. See, I'm being very explicit. And so that gives me 6 is less than 3x is less than 8. And she's exactly right. We got to watch out for like minuses. But here, we're okay. Divide by 3 is something we can do. So we get 6 over 3 is less than x is less than 8 over 3. So what's the solution? We get, 2 less than x less than 8 thirds. And in interval notation, that is 2 to 8 thirds. That's the solution here. I will pretty much always ask you to write your answer in interval notation. All right? What happens with this example if instead of less than 1, I do greater than 1? And what if I put greater than or equal to? How's that go? See, then I'm up against 2 inequalities, all right? I'm up against, on the one hand, 3x minus 7 less than or equal to minus 1, or I'm up against 3x minus 7 greater than or equal to 1. I'm using the theorem, which is nothing more than the logic that you saw in examples 9 and 10, all right? It's exactly that, just generalized. And now we have inequalities, right? So we can solve these. Add 7 to both sides. You've got 3x less than or equal to 6. Over here you've got 3x greater than or equal to 8, which gives us x is less than or equal to 6 over 3, which is otherwise known as 2, or x is greater than or equal to 8 thirds. So the answer is minus infinity to 2. This time 2 is included, unioned with 8 thirds to infinity. So there you go. It's got two pieces. The square bracket means we're including the number, right? The parentheses means it's excluded. So you guys totally up to date on your inequalities without the absolute values? You guys are okay on that? I mean, let's just work a problem here. So let's just drop the inequalities here for a second. I mean the absolute values for a second. Let's just talk. Oh, thanks. Let's talk about inequalities just for a second here. What if we had something like, oh, I don't know, 2x plus 3 less than 7 minus 2x, right? So let me just do something kind of dumb. All right, I'm going to subtract 7 from this. So if I subtract 7 from both sides, I get 2x plus 3 minus 7 less than, minus 2x, right? And then I'm subtract the 2x to the other side. I get minus 4 is less than, minus 2x, otherwise known as minus 4 is less than minus 4x. Sometimes you do something like this, right? And you find yourself with a negative coefficient for x. This is where we got to watch out. Because if we want to divide by minus 4, right, the step is this. Minus 4 over minus 4, watch this, it has to be greater than minus 4x over minus 4. When we divide or multiply the inequality by a negative number, we have to flip from less than to greater than or vice versa. And so what do we got? 1 is greater than x. And for, what is that? Well, that's the same as saying x is less than 1, right? That's another freedom we have with inequalities. We can rewrite them left to right, right to left. But when we do that, we have to be careful to flip the inequalities. What's the solution set here? Anything less than 1, which is minus infinity, right, to 1. 1 is not included here, so we do the curly bracket like that. So, yeah, parentheses means not included. The bracket means it is included. Yeah. Anyway, I think that's it for today, guys. So, see you Thursday. Mm-hmm.